The problem is we are given an integer n. We have to represent it as sum of non-consecutive Fibonacci numbers. So this concept is called Zeckendorf pattern. So Zeckendorf problem or Zeckendorf theorem states that any positive integer can be represented as sum of non-consecutive Fibonacci numbers. So here this is our question. So we'll be given a number. We have to represent it as sum of non-consecutive Fibonacci numbers. So basically what they're saying is we have a Fibonacci series, right? 0, 1, 1, 2, 3, 5, these series. So we have to represent a number with these Fibonacci numbers, but they shouldn't be consecutive. Like if you are using 1, you cannot use 1 or 0 again. And if you are using 5, we cannot use 3 or 8, as 3 is the previous number of 5 and 8 is the next number of 5 in the Fibonacci series. So that's the concept. So we can use two methods to solve this. First one is to generate an entire Fibonacci series till the number less than the given input, right? This is one approach. The other approach is take a number, generate a Fibonacci number that is less than the given number, and then subtract this obtained value with the actual number, right? For example, we are getting 65. To generate a Fibonacci number that is less than 65, it is going to be 58. So the next remaining will be 65 minus 55. It's going to be 10. To generate next Fibonacci number that's less than 10, it will be 8. The remaining is 10 minus 8, 2. Generate Fibonacci number that is less than 2, less than or equal to 2. This is going to be 2. This is one approach. Now the other approach is generate all the Fibonacci numbers that are less than 65 and store them in an array. So we'll have from 0 to 55 in the array. Now iterate this array in the reverse order. If we cannot represent it as sum of non-consecutive Fibonacci numbers, return -1. That's the approach. So it will become a lot more easier if we can use array list, but we cannot use any collections. We can make use of arrays. Let's move on to the coding part. I'm going to be using IntelliJ for coding. So till now we have got an input for the number. Let us generate a series for it. Let us declare an array. So size 50 would be enough to store these. Now let us start with the Fibonacci series. First element is going to be 0. But since we cannot represent 0 in this combination, let us start from 1. So this right, it is going to represent the index. So now we have two elements. Now it should represent third, which is index 2. Let us get into the looping part. So our condition should be, so we know this one, right? F1 equal to 0, F2 equal to 1, F3 equal to F1 plus F2, right? This is how basically Fibonacci program works. So here we're not going to be using these. Here arrow of 0 is F1, arrow of 1 is F2. Arrow of, I mean, the array of 2 should be F3. Instead of that, we are going to be using right to represent its index. So here inside the while loop, it is going to be arrow of 0 plus arrow of 1, F1 plus F2 less than equal to the n obtained input. So instead of using 0 and 1, we can use right minus 0, no, right minus 1 and right minus 2, right. So initially right is 2. 2 minus 1 is going to be 1, which is F2. 2 minus 2 is going to be 0, which is F1. So that's going to be our looping part. Let's remove this. Arrow of right plus plus equal to arrow of right minus 1. plus of right minus 2. So that's it. This is the loop to generate a Fibonacci series. That will be stored in the this right. Now the next part is to generate the Zeckendorf series. So let us create another array. So let us call it store the resultant array equal to 3 would be enough most of the cases. Now we'll need some additional variables. So first one is to keep track of how many numbers have been used in the resulting array. Let's call this as what can you call it? And call it as track to keep track of it. Track equal to 0. Now we are going to be needing another variable which is going to keep track of the last index from which the Fibonacci number has been taken from this array, right? So let us call it as last index equal to, let us say, minus 1, right? We cannot say it as 0. If we are saying it as 0, it means that the first index, so it cannot be 0. So we are using minus 1. Now we need another variable to keep track of the remaining, right? So while getting input 65, after subtracting 55, the remainder is 10. So this 10 should be stored here. So let us call it as remainder. Initially it's going to be the same. So let us say it as n. Let's start the looping. We are going to be iterating from the last element of the generator array. So the last is going to be the size is, I mean the size of the array is right. Int I equal to right, I greater than equal to 0, I minus minus. That is our looping condition. That's our loop condition. Oh, actually minus 1. Since here we have used less than equal to right, so it cannot be equal to the same number. So right minus 1, a number less than the given input. So we have to check if it is less than the remainder. R of I less than equal to remainder. Okay, if it is less, we can continue. Let's move forward. So we can check next condition. We have to check whether it is the next Fibonacci number in the series. Let's check for that. If I equal to last index minus 1. When this happens, we cannot represent it as a sum of Fibonacci numbers. I mean, sum of non-consecutive Fibonacci numbers. So printing it, we are exiting the loop. If not, we are continuing further. Rest of track plus plus equal to R of I. So we are adding this Fibonacci number into the resultant array, and then our last index becomes I, and remainder becomes remainder minus R of I. That's the looping part. Let us print it. If remainder not equal to 0, it means that it cannot be represented as sum of non-consecutive Fibonacci numbers. If it is not getting 0, it means that it cannot be represented as a sum of non-consecutive Fibonaccis, and we are printing not possible. If not, if 0 is attained, it is possible to represent it as a sum of non-consecutive Fibonacci numbers. So now we have stored these series in this array. So we are going to be printing this resultant array. We can do that using a for loop. So I equal to 0, I less than the size of the resultant array is going to be equal to track I plus plus. So that's the code. Let's execute it now. Let's give the input as 65. I'm getting an index out of bounds exception at line 12. Let's look at it. Let's try and change this. Let's try now. Yes, it is working fine now. Let's check for another output. Let us check it for 81. Yeah. So this is the code. This is the code, and that's the output. I'll post these in on my GitHub page. I'll give a link in the description. Feel free to check them out. And if you have any other questions or want me to cover some specific concepts, drop them in the comments. I'll try to cover them.
Hi guys, I'm Zeckendorf. If you found this video helpful, like, consider subscribing and share it with your friends. Thank you.